Our webinar has started, so welcome to everyone that is on Zoom as well. Welcome to our Sustainable Product Design and Innovation Senior Portfolio Review. So I'm Dr. Lisa Hicks. I'm the chair of the SPDI program. We are really glad to be back in person. It's really wonderful to see all of your, I'm assuming, smiling faces behind those masks. So it'd be great to have you be able to talk directly with the students. Now, also here at Keene State, we've done really well coping with COVID. We'd like you to keep your masks on while you're in the classrooms and in the labs and when you're networking. And that would be appreciated. I'll take it off while I'm speaking so that you can hear us well. And each student can do that when they come up. You can take your mask and then put it back on. That'd be great. So let's see. So, okay, so when these presentations are done, you're all invited to go out into the lobby, into the labs, and circulate around. The students will be there with their projects, and so you can ask them questions. And then we'll have a small industry advisory discussion and dinner with some of our alumni and industry folks upstairs at 6:30 afterwards. So also, again, we're in person. And so I'd really like to introduce some of our faculty that you probably haven't been able to meet yet. And so is Dr. Habib? There he is. Okay, so Dr. MD Hassan Habib is one of our great SPDI faculty members. And so, hi, glad to meet you. And then Dr. Jared Nelson is in the back there also. So our other new. And also our wonderful lab managers, Curtis Mead and Warren Hurd, which I think actually might still be out in the labs, but there's Warren. Okay, great. And then we've also got some wonderful adjunct faculty members that are here as well. Jim Wing, I'm seeing helping us with the ultra precision. And then Patrick Joyce helping us with electrical engineering. And Jim Kyle helping us with design for manufacturing and assembly. Let's see who else is here. So let's see who else has helped us. Chris Ponce, Amit Patel, Matthew Bickford also have helped us. And then also just a shout out to Jim Pelto, who retired last year as our machinist faculty member, has been great at helping the students with those. So I have a few announcements before we start. I'll try to go through these quickly, but we have some really great things that have happened in the last few years. So we've been working with our program and our math and science programs as well. And so students, along with their SPDI program, if they choose to, can take additional courses and earn an option in manufacturing engineering or general engineering. We also have some new courses and pathways in mechatronics and automation, in the emerging field of biofabrication, and also in ultra precision manufacturing. We've also collaborated with John Tomachik. I think he's here. There you are, yes, at Smith's Medical and with Nashua Community College. And we're offering an automation apprenticeship program also, which is great. Another thing that's been a great help to us at Keene State and to our program is we're part of 2 statewide research and workforce development grants with Dartmouth and UNH. One of them is the National Science Foundation EPSCoR BioMade grant, and then also the National Institute of Health New Hampshire IMBRI biomedical grant. And that's a really big deal. It's really been supporting both faculty research and undergraduate student research. So they've been able to get involved in some really exciting work. And then I just want to do a shout out to Dr. Habib here. There's going to be an article about his work, but he's been a great mentor to our students and especially to 2 students, Carter Nelson and Amar Abatello, and then also a couple of juniors, Sleisha Tulador and Connor Quigley. And they're going to be presenting some papers at 2 conferences this summer. So that's some great accomplishments. So let's see. Oh, also the grants have been able to improve some of our lab capabilities. We now have a universal testing machine where we can do tensile and compression testing, and a rheometer for testing viscosity and shear thinning on some of the biomaterials that Dr. Habib's group is working on, and also a research level or a few research level bio 3D printers. Again, Carter and Amr have been rock stars in the biofabrication research area. So lastly, we've got a really great, I call it an opportunity. We've had a major $500,000 gift to the SPDI program from an alumni honoring one of our faculty emeritus, Delmar Ogg. And this is an endowment that has been created to help with faculty development, to keep us current, and also with student scholarships. So, so that's great. Now, the other wonderful part of this is there's a challenge. And so if we can raise another 500,000 to support the SPDI program, and it can be for anything, then they will match with another 500,000. So we're really excited about that and what it can do for our students and our capability and for our program. So we are super excited about that. Okay, so let's get going here. So first, the students will present quick recaps of their team projects, and then each student will show a few of their own projects. And as you'll see, each student is a very different person. Each is developed at their own pace, each finding their own interests and developing their strengths, as well as shoring up areas that need strengthening. Some are eager to start their careers. Some are thinking about graduate school, but all of them have a lot to offer the world with both their directly applicable skills and their many transferable skills. And I just want to say we're very proud of them. So with that, the SPDI group is up first. So come on up.
Hi, I'm Kyle.
I'm Ryan. I'm Palmer.
And I'm Ian. And this is the SPDI, a 3D printing filament dry box. So one of the biggest issues with 3D printing is wet printing filament actually causes a lot of problems. So we wanted to see just how much wet filament was actually affecting prints. So we left some filament in water for 24 hours and then printed with it versus the same dry filament to see the difference. You can kind of see over there, it causes a bunch of droops and like weird lines that you wouldn't want to see on a print. And then we also tested the seals on the box to make sure that the humidity outside was actually different than the inside.
Can you hold the mic up a little closer?
Yep.
Thank you.
This is our prototype progression for the SPDI from initial ideation to final prototype. We started out large and scaled back the design based on the needs of the target user and test data.
This is the showcase of the final product, and it features a SPDI hooked up to a Ender 3 V2 3D printer.
These pictures show our final assembly of the 10 boxes. In these pictures, we're fitting the top acrylic, adding the fittings, gluing magnets, and inserting the sensors. After the assembly, they're sold for a profit. You can see more details on each of these steps in our individual presentations and see our live demonstration out in the main lobby.
And next up is the kayak launcher group.
All right, can I be heard? Yeah, we're good. All right. So our group project was the Kayak Caddy, a kayak launcher. And the goal of our project was to make getting in and out of a kayak a lot easier. So the hardest part for many people of getting into a kayak is trying to balance when you're in the water, as well as trying to balance when you're getting out into the shallow water as well. Obviously, the boat can tip, you're in the water, it's not even ground. There's a lot of variables that can happen. And for a lot of people, that's just too much to deal with and they can't kayak. So we decided to take the entry and exit of the kayak and bring the entire thing out of the water so that you get into the kayak on dry land and then you are rolled into the water. That way, it's a strong, stable surface for you to sit on and you won't be sliding around or, tipping the boat over trying to get in.
Try to remember to put right up next to your mouth.
So this project was a long time in the works. We worked on it for a full semester from start to beginning. With each design change, we built prototypes. We had a total of 7, including the production model. And through there, we had to make various design changes. And as you can see on the top, which was our first model compared to our production model, it went through a lot of design changes. For that first one you see there, our project manager, Amr, actually sat on it, but it only held up for like 10 seconds before the wheels fell off. So that was a big milestone for us, so that was good.
Yeah, too bad you guys, we don't have the video of us. Our initial launch at the boat ramp. How cold was the water? Probably it was freezing.
We found the only part that wasn't frozen on the lake.
You can see in the picture, yeah, it's all frozen in the background there, but. So some of our tools we worked on for the project, you can see all our materials right there, some of them before we assembled. There was a lot of woodworking in the project for the seat. We did metal work, lathe work. We did knurling on the handles. That was my idea. Create Gantt charts to help us track our progress, work instructions, bill of materials, quality control sheets, things of that nature. You can see L carving out the kayak, what do we call them, the supports, which are made out of PVC. And I encourage everyone to check it out. We have them in the hub, and we have
3 available. If anybody wants them, or anybody's interested, we have 3 available for sale at the right.
Discount too.
We'll cut you a hell of a deal.
Next, we have the chaotic pendulum.
Hi, everybody. I'm Sam Foley. I was the project manager for the Chaotic Pendulum.
I'm Catherine O'Leary, and I was manufacturing engineer.
I'm Nathan Maxwell, and I was the design engineer. And I'm Sam Cloutier. I was the quality control accountant.
All right. So just as a little introduction, the goal of this project was to create a appealing art piece based off the chaotic motion of a double pendulum. The initial goal was, we wanted it to be capable of human interaction. So we wanted people to be able to go up and interact with it in some way. Yeah, we just have a couple of the different materials that were used in construction.
So throughout the project, we went through a couple iterations, but there was 3 major steps. The initial concept where we didn't quite know how a pendulum worked. The initial prototype, which is a lot better, and it spun for about 3 minutes on its own. And then the production prototype that we inevitably made, which was very colorful.
So this here is all of our parts on one slide. So the first, we have the acrylic circles and the acrylic arms. Then we have the MDF, which is the backboard. Then we use bearings for the spinning, and we actually use bike lights for our glowing aspect. And then we used magnets so that they can move the other arms.
Hello, we are the Oya Fire Pit Group. Our vision for this was to make a fire pit that incorporated sustainability, so we reused stainless steel kegs. We had a whirling tornado on top that helped it burn hotter, brighter, and faster and light much quicker. And then just the cool aspect of having a tornado and having something to hang out outside and keep you warm with your friends. We did a lot of prototyping for this, many of which were our production prototype and then ended up not being our production prototype. We started small and changed a lot of stuff to figure out how the airflow would work. And then we got bigger, tried to figure out what looked the best. And after our final production prototype, we changed all of our materials and made it look a lot better, but that was the concept that we were going for.
Yeah, I'm Brian Everett, and I was the manufacturing engineer for this project. And these are just some of the manufacturing processes we used: MIG welding, spot welding, laser cutting, plasma cutting, knockout punching, riveting, just to name a few.
All right, and here you can see our final product. So we ended up making 8 of the fully finished stainless steel fire pits. We gave all of them custom paint designs, as you can see here. And then here's a couple of pictures of them actually in use. This is one of our professors, Jared Nelson, using it with his family on a cold winter night or day. And then here's me and my dad actually testing out at home. And I'm pretty excited to go back and use that this summer some more. All right, and then I think that takes us to the individual portfolios.
So I guess I'm leading the charge here. Hello, everyone. My name is Albert Mejia. So a little bit about me. I was a transfer student. I went to a 2-year school, New Hampshire Technical Institute. I studied industrial design technology there, and then furthered my education to Keene State College. Some things I like to do on my free time: be outside, work on the computer, use different programs, or if I'm not doing any of those things, I like to work on my car as well. Some qualities about me and some skills I've learned. Get right into it. So last summer, I had the opportunity to have an internship at General Electric Aviation in Hooksett. They're an aerospace manufacturer. They make aircraft components. Specifically, that plant makes the compressor portion of the engine. They have 3 sectors, or 3 different sections: tubing, sectors, and blisk. I got to work on a blisk, which is a rotating part of the compressor. So it requires a little bit more work, more specifically small blisk. Large blisk is for the F-16s and commercial jet airliners. And small blisk is for the Apache helicopter and the Black Hawk. That is the T-700, which is the engine line I was working for. I was with the technical team under manufacturing engineer. I did some data analytics for them, some redesign a workstation for one of the parts, fixed a 3D printer, and worked on some Pareto charts to tell the engineers what to focus on. Next is my dial caliper project. Our teacher, Jim, told us that pick something that you'd like to, that would relate to something you wanted to do after you graduated. So I thought this was appropriate. I picked a 6-inch dial caliper, took it all apart, ran some tests, Rockwell hardness to find the materials of it, did a float test to find all the plastics of it, and some mass properties as well. I drew it up all in CAD and did a cost analysis sheet with all the different components and the manufacturing techniques they used. And I also rendered it right here. And I obtained a lot of skills. Next is the kayak launcher project, a huge project. I was a design engineer. I provided CAD prototypes for our designs. And also I mostly focused on building the kayak supports and bringing those to market. There's a final assembly of it and the final production model. And this was a really cool experience working as a team. And yeah, it's just like real industry. So that was a great project. And this one is extensometer modification. one of our customers wanted, if you don't know what an extensometer is, it measures the tensile strength of fiber. It pulls it and then measures the tensile strength from there. But how it was currently, you weren't able to adjust it. So you could only do a fixed length of fiber. So our customer wanted us to be able to extend it. So he could do like fiber that was like 1 through 8 inches long. And we came up with a monorail design and machined it up and came out with the final product. I did work in tandem with another student here, Tyler McNano, so credit to him as well. So yeah, learned a lot, had to do some engineering drawings that I actually used out in the shop while I was machining the parts, so that was great. Now, a word from the great Ian Henning.
I'm gonna apologize right now if you can't tell my voice is already starting to go, but I should be able to make you all hear me.
Oh my God, that'll help a lot.
I don't know if that's gonna help. So obviously I'm a senior here, I'm a SPDI major. I have a minor in business management and entrepreneurship. A little bit about myself. I was the former president of the Sigma Pi fraternity here on campus. I love sports, honestly, anything. If I don't know how to play it now, I will learn. And I love doing anything outdoors or working on anything that has an engine, literally anything. So for my first project was a splitter for the front of my car. I actually went out there in the freezing cold, as you can see in the winter there, and mocked up a cardboard model and then took it down into my basement and actually made a fiberglass composite and then attached it to the front, which you can see in this one. I went through all the steps. I went through the mold, the first couple of layers, refining that back, body filler if needed it, spot putty, painting, priming, sanding that back, clear coat, all of that. From there, I moved on to, again, these are all a lot of automotive-based parts, but this actually replaces an OEM part that you can get from Volkswagen. That one on the far left costs, I believe it's about $50 for something that's injection molded and is about this big. This one right here, I actually 3D printed. It takes about 3 hours and like $2 for the material, so it's much cheaper. And it actually allows you to put in a gauge pod for something like an oxygen sensor, a boost sensor, something like that. So you can tell how well your automobile is running. This is trunk storage. I did this here as a sophomore. You can see the first sketches I have and some dimensions of products that would go into it, to dimension CAD models, the final CAD model there on the very bottom to the final product here. This is another automotive part. I actually did this just for my car because my car is actually push button start and I lose my key constantly. I will lose my head if it's not screwed on tight. So I really need a place to put it. So I actually designed a place to put it right in my center console. And now if it's not there, I tweak because like it should always be in that spot. This next one is actually a universal license plate mount to go on any car with a honeycomb front grille. It just snaps on from the front and from the back, and there's 2 screws that cinch it down and keep it in place, and it lasts through like 20,000 miles. It does not fall off. So this last one is actually my current PD3 project. I'm a type 1 diabetic, have been for 19 years. It's a near and dear project to me. And one of the biggest issues with using an insulin pen is actually, like right now my hands are sweaty because I'm nervous. So like if I try to give myself a shot with it, it tends to slip and slide and it's not very safe to use. So I actually designed a device that makes it much more secure in the use and gives you a lot more variability to the angle and like usability of the device. And actually I used it like about 20 minutes ago to give myself a shot. So it does work and it works very well. And this is the SPDI filament box. I was the accountant on this one, so I ran all the numbers. I calculated how many products we need, how many bolts, nuts, all of that. And then I also helped do some of the testing. So for the final product, we use fiberboard, and I actually helped do the testing for that to figure out exactly how fast we need to go for that, the temperature, all of that. Here is William.
Okay. Okay. All right. My name is William Mullen. I enjoy being outdoors, working on cars, and designing and building all kinds of projects. This is my manufacturing enterprise project. We created a pendant lamp and successfully manufactured 10 units in a test pilot run. My job during this project was the electrical design and manufacturing. I researched UL regulations to determine how to make the proper connections and wire strain reliefs. I also got track of my time and money spent on design and prototyping the electronics to keep accurate records of our work. This was a product design project I created. My observational research discovered the problem of finding the right wrench for doing an oil change. This wrench has the 6 most common sized oil drain plug sizes in the world built into one tool. I explored various designs to determine the best configuration, and I also got to build on my welding skills during this project. This is my cardboard chair project. I collected and incorporated my anthropometric data into the design. We had to build it using no adhesives or fasteners for a sustainable, fully recyclable design. It also had to be able to fully support me sitting in the chair for over an hour, which it successfully did. And prior to constructing the full-size prototype, I made a quarter-size scale model. This is my advanced 3D CAD project. It was a group effort to recreate all the components of a pressure washer engine in SolidWorks, and at the end of the course, we put them all together into an assembly. I was able to take precise measurements and accurate measurements of all the radiuses and draft on the component. This was our mechatronics and automation class project. We constructed a low-cost mechatronics trainer candy dispensing machine. I constructed the linear conveyor and built the platforms contributing to the team project. I also learned how to program the PLC and servo driver using the Click software, and also followed wiring diagrams to complete the electrical portion of my components. This is a frame-off restoration of a 1981 Jeep J10 that I began when I was 15 years old. I did a complete engine and driveline rebuild, learned how to do auto body work and rust repair using sheet metal weld-in techniques for lasting quality. And not a single bolt anywhere on this truck went untouched, and it's still a work in progress, but after college, hopefully I'll get a little bit more time in the evenings to complete the whole project. And finally, this is my capstone product design project. Observational research discovered the underutilization of a remote start system. I learned a lot about electrical design, and I also got to learn how to write code to run an Arduino, which is essentially a reprogrammable microchip to run the system. And I also included a modular tray design, which allows for ease of use with many different models of cars. And next up is Nate.
Hi, I'm Nathan Maxwell, and I'm a speedy major, obviously. A couple of things I enjoy are my lovely 2 dogs and going to the beach with my family. So the first project I'm going to talk about is a project I did in my CNC manufacturing course, which was a little fidget spinner toy. Obviously, one of these designs is a bit different than the other, but a lot of this project was just me balancing it out. It is exactly 2-to-1 ratio, and it fits perfectly in my hands, which was the sole intent. And it was very fun to make. I did a lot of work in CAD and CNC with it, and it was the first time I ever really did that. This was our Mechatronics Enterprise class with Dr. Habib. It was pretty fun. We had to work on a machine that would feed candy into a loop with 2 separate heighted cups and would sort it based on color and size of those cups. And me, Amr Abatello, and a buddy of ours, Colin, ended up working on a new section for it. And a majority of my work was making a whole funnel for it, as well as these 2 redesigns of the cups that are inclined perfectly to make it so no matter what angle, you can dump out all the candy effectively. It was pretty fun to make. A lot of fillets. has been talked about before, but this is the cardboard chair project that we had to make. It was a lot of fun, actually. I've never really done anything like this before, just cardboard. And it surprisingly held my weight for more than an hour. This chair sat in the other room for, I want to say, a couple weeks and was used commonly because it just existed in there and it worked well. This is the last project we did in product design 2, which was solving a storage issue. The storage issue I was looking into was the storage and renovation of small bits and screws that get lost throughout the shop. Anyone who's been in a shop understands that pain. And throughout the design, I went through a couple different designs and eventually ended up on a giant wood disc that spins on top of another segmented piece. And it's came out pretty nice. And this last one is, we've talked about before, the chaotic pendulum. A lot of the work I did was CAD models, tolerancing, and making sure everything spun well. We had a couple stages. My favorite stage was honestly the third concept. It was where I started figuring out how a pendulum worked. And it, like I said, spun for a full 3 minutes when you flicked it, and that tickled my fancy pretty well. And I believe that's it. Next to Sam Hales.
All right, so I'm Sam Hales. A couple things about me. In my free time, I like writing and playing music. I like being outside like a lot of the other people here and traveling new spots with my friends. And I picked the major because I just wanted a new way to use my creativity, and I think I got some nice challenges out of that. So yeah, back to the Oh Yeah Fire Pit project. I was the accounting manager on this, which brought up some unique challenges trying to manage the costs that went into it because the materials were pretty expensive, which led to the idea that I had to reuse old stainless steel kegs, which happened to be the exact 304 stainless steel material we needed. And other than that, my favorite thing about this project was just the teamwork. It was a really great group, great chemistry, and I got a lot of value out of that. This is my cardboard chair project. I based it off of anthropometric data as well as a dining room chair that I had. And it's not too much to say about this one. I think it came out pretty good though and held up my weight for an hour. So it was a success for the requirements of the class. This is a DJ equipment rack. I made this as our organizational project to organize the DJ performance equipment. And yeah, this still gets a lot of use. I gave it to my friends to use at their house, and it's pretty awesome to see it used as intended. And last is my current project, which is a hiking sandal. So I wanted to make something that was a cross between a sandal and a boot, because I go swimming a lot of places in the summer that you have to hike to, and it's annoying to have to switch shoes and carry an extra pair. This one's actually still a work in progress, but I just started attaching the straps, and you guys can see it out in the lab in a little bit. And also this project, I got to do a lot of experience with some advanced CAD concepts and got kind of a crash course in plaster mold casting. And here's just some process photos from that. You can see there's some pretty complex multi-step casting that went into it. And moving on to Sam Cloutier.
All right, how's it going, everyone? I'm Sam Cloutier. A little bit about myself. I'm in the SPDI program here, Keene State, and I'm also have a minor in business management. A little bit about myself. I enjoy the outdoors, sports, and I used to play baseball here. Another thing about myself is I have a little bit of a background in diamond turning. I took the first go around of the course taught by our professor Jim Wing here. It struck a pretty big interest with me, and I ended up going to get a job at Corning as a diamond turning operator. From there, I was also a teacher assistant for Jim Wing and another go around in the course. And I'm continuing my work in the industry as a diamond turning operator at 603 Optics. This was my Product Design 2 project. It was a precision desk organizer. The main idea of this was for the precision area of the SPDI lab. I did a lot of work over here just based off of me being a TA. I did this project alongside of that, and we had a lot of tools and a lot of other equipment that needed a home. So I put together a device that would help sort all those things. This is the chaotic motion pendulum. We already went over that. This is basically my work in the project was I was the quality control accountant. I did a lot of work with quality assurance, our prototyping, making sure everything was looking good in all of our prototyping and final product. I also did a lot of work with like our logos, a lot of work with our posters and promotional video. This is a project I did for my competitive manufacturing management project. I also did this on the high precision manufacturing area of the SPDI lab. When we did this, we were doing the first go around of that class. And so I did this alongside that. And we pretty much documented the progress and got good feedback and a lot of tools in for the class itself. Like we added a big TV that would be projected over the machine itself, and there'd be a camera on the inside of the machine, so it was easier for students to see inside the machine instead of all huddling around, because it's a pretty enclosed piece, and with COVID going around, it made it easier for students to stay spread out and easy to see. We also had a few other things, such as desks, storage places, metrology equipment, and lots of other equipment that was brought in during our project. This is my advanced CAD SolidWorks airplane part. I had the oil pan for the part. We disassembled a small airplane engine, and each student in the course got their own designated part and had to fully model it to its exact form. So this was a little bit of how I did it. I had a master sketch with dimensions that was actual size that I traced. This is where I was able to keep all the actual dimensions of the piece. And then I was basically just went through all the steps, and yeah, this is the final model. This is the actual part itself. So yeah. Now I'm gonna bring up Palmer.
Hi, I'm Palmer Bolowski. And this is a short version of my portfolio. These are some of my skills and qualities and pictures of me doing things I like and with people that are important to me. So this is my advanced CAD project. It's a flywheel for a lawnmower engine. The challenge was to disassemble a lawnmower engine as a class, and then each student was assigned a part to model and recreate in SolidWorks. And this is what I came up with. This is my Product Design 2 project. I wanted to solve the issue of drying dishes in small apartments that don't have dishwashing machines like mine. I did design research, observational research, ideation and prototyping until I came up with my final design, which was this, which we did use at my house. This is my DFMA project. I did a wine opener. in this class, I took apart the wine opener and determined the materials used in manufacturing it. I created a SolidWorks model as well as drawings of each of the parts, and we figured out the costing that it would be to manufacture one of these. This is what I'm currently working on right now. I'm redesigning a locker. As you can see, our locker room is pretty messy, and I wanted to come up with a way that would be a little more interactive with people to be able to keep the locker room clean, not only for us, for the people that have to clean it too. I've taken this project from sketching and ideation all the way up until where I'm at now, which is my prototype. I still am working on a final model that will be made out of MDO and starboard. And that's currently still in the works. And then I was part of the Speedy Dry group. This was a group project for my manufacturing enterprise class. My team and I designed and manufactured 10 of these boxes and sold them for a profit. A lot of the work that I focused on was getting Laser Cutter to work correctly for us and transferring a lot of our files from SolidWorks files to Rhino, as well as I did a lot of the quality assurance for each of our parts to make sure that throughout the whole process, each part was up to our standards, which commonly was not the case. And now I'm bringing up Ryan Bevins.
Can't put this right here. You guys hear me all right? No? How about now? Better? All right. Hello, I'm Ryan Bevins. Some of my interests are skiing, fishing, working hands-on, and being outdoors. Here are a few of my skills and qualities. For my manufacturing enterprise class, I was also a part of the Speedy Dry group. I was the manufacturing engineer, so some of my responsibilities were Gantt charts, process sheets, work instruction, routing sheets, and then I actually did a lot of the finishing and painting of the box, as well as final assembly. So for my design for manufacturing and assembly, I chose for my project vacuum insulated koozie, and kind of reverse engineered it. And we looked at the breakdown of the manufacturing process. We looked at material selection, material cost, labor cost, tooling cost, and move time. Using all this, I was able to get a total cost, estimated total cost, and total gross profit. For my CNC class, I chose to do a Ford logo. I designed a part in SolidWorks, took that and put it into Mastercam and programmed it to be ran on a Haas mill. We looked at feeds, speeds, G-code, and I was only able to run it on pattern board, and it came out really well. But due to lack of time, wasn't able to run it on aluminum, but hopefully in the future I'll be able to do that. For my product design 3 class, I worked closely with Daniel Henderson, who is actually here today. He came to us with a problem in his car. He has an assistive car, so he drives the car with his hands, and the seat of the car actually comes out, so he'll be able to transfer from a wheelchair into his car. And one of the problems he had was that when they put that seat in, they had to get rid of the armrest, and so that was a problem because there was no support on his right side. So when he would take left-hand turns, it was very dangerous for him. So myself and my partner kind of came up with an idea for something to go in between the center console and the seat that is comfortable and gives him support. It's adjustable up and down and is easily removable. And lastly, over the summer, I had the opportunity to work for Whitney Brothers here in Keene. They make furniture for early education. And my position was a manufacturing project specialist. So I did a lot of work with production flow, machine efficiency, recorded downtime and efficiency numbers. And one of the machines I worked on was the UV edge coat machine, and which was a bottleneck in their production a little bit. So kind of just added a few things to the machine that'll help increase the efficiency and make things easier for the worker. And I'd like to thank Mike for the opportunity to, and appreciate it. Thank you. Next is Ryan.
Hi, I'm Brian Everett, and this is my portfolio. So a little bit about me. I'm a SPDI major, just like everyone else here. I'm also a business management minor. These are some things I enjoy. In the summers, I love sailing. In the winters, I love snowboarding. I also love working on engines and stuff. I have an old Volkswagen that I work on. That's a small Briggs and Stratton engine I took completely apart and put completely back together. I have Volkswagen engines completely apart right now, but I have not put that back together yet. So this is a current project of mine. It's a cooler for a graphics card for a computer. So the problem I set out to solve was just making an improved cooler, just able to cool the heatsink more efficiently. And I also want it to be easier to remove for maintenance, like such as cleaning the dust out. Yeah, the reason you want adequate cooling is because lots of stock graphics cards don't have super strong coolers, and if they overheat too much, it could shorten their lifespan, and it could also bottleneck performance. So this is the testing setup, the test I set up for it. So I came up with a bunch of different models and prototypes, a lot of 3D printed parts, and the way I tested them was I used some software called Furmark. It's just a GPU stress test. It basically just animates a really complex video and monitors the card's performance. So right there, you can see a graph of different cooling setups I tried, different prototypes of mine. Yeah, and these are just a few of my prototypes. There was a lot more, but I started out with ones that blew air into the bottom of the heatsink, just like the stock fans do. And then I moved towards a design that blew it in on the side, and I actually realized this could solve a different problem. So some VFX artists usually have multiple graphics cards, and they're stacked right on top of each other. So the top card is actually getting choked because there's another graphics card right under it. So the fans can't really suck in air too well. So I actually designed a cooler that blows air through the side of the heatsink instead. And yeah, it works pretty well. That's a nice exploded rendering I did of it, and that's it in its current form. You can see it in the shop later. It's done for now, but I definitely want to work on it more in the future. Definitely has some room for improvement. Yeah, as I mentioned before, I was the manufacturing engineer for the OEF fire pit. Some of my responsibilities were designing and constructing jigs, fixtures, and templates, and also choosing manufacturing processes and materials. On the top is some shots of me in action. And the bottom left is the junkyard we got all the kegs from. That's me digging a keg out, some other junk. And yeah, on the bottom right, that was taken like minutes after we finally finished our production run. That was a very happy moment. This is an example of some of my CAD modeling and rendering. So this is for, yeah, the advanced CAD class. We each got a piece of a Lycoming O290 airplane engine. I got the piston assembly for it. yeah, that's just the progression of the connecting rod on the left there. But yeah, the final model's in the middle, and that's exploded rendering I did of it. Yeah, so the CAD software uses SolidWorks, but I have a lot of experience with that now. This rendering I did with the built-in rendering software, PhotoView 360. It's inside SolidWorks, but I also have some experience using KeyShot. And yeah, now Ryan Murphy is up.
Hi, can you hear me? I'm Ryan Murphy. I'm a speedy major with a safety minor, occupational safety. I'm the former president of the Keene State Fishing Club. I was it from 2019 to 2022. Some things I'm interested in is old Ford pickups. I had two, I have one now. We'll see how that turns out when I graduate though. I play the banjo. I actually had the opportunity to perform at a friend of mine is a DJ for UKNH here at Keene State. So we had a little concert in the fall of last year. I'm an avid hiker, obviously fisherman. Oh, and I was involved with the Boy Scouts of America for over 10 years. I'm an Eagle Scout. I had the opportunity to work an internship at Lennox American Saw in East Long Meadow, Massachusetts. They're owned by Stanley Black & Decker now. I worked there summer 2020 and summer 2021 and winter 20 in between there. Some of the products you may be familiar with are step drills, hole saws, reciprocating saw blades, and industrial bandsaw blades. I worked on some scrap reduction projects, optimized cycle times on Anka grinding machines, which make these step drill bits. Those are actually ground out of bar stock, so they're pretty strong. I implemented a new program with Keon's vision systems. Basically, it's a new type of almost like a CMM where you can put a part underneath it, push a button, and it will basically tell you if it's a good or bad part. Basically, you'd put the bit into a 3-jaw chuck, and it will check the outer diameters for you using lasers. So I had to do that for each part, put in the dimensions, and do all the programming. I edited ISO documents, CAD drawings, and I communicated with vendors for bringing in new manufacturing processes into the plant. And my title was a manufacturing engineer, by the way. And I'd like to thank Marty Morris and Ryan Duvall for the support while I was working there. So my first project, I've had this pickup truck since I was 15. It's a 1966 Ford pickup. I drive it every day except in the wintertime. I've probably put somewhere around almost 40,000 miles on it with, knock on wood, never has broken down on me ever. It probably won't start today or something. I did a lot of welding, a lot of rust repair. You can see here, that's the after and the before. Basically, I ended up putting a whole new front clip on it. In 2018, before I came to college, I did an engine and transmission swap. It was an automatic when I bought it. I converted it to a 4-speed with granny gear. I put a 1978 Ford 300 straight 6 in it. And I upgraded the brakes on it as well. That was in the last slide, but I did power disc brakes in the front, which made stopping a lot more safe. And you basically had to stand on the pedal before. It was drum brakes all the way around, non-power. It was pretty scary. Pretty sure that was just for like cruising around on farm dirt back roads back in the day, not actual traffic. I did MSD electronic ignition, so I got rid of the point system. And then last summer, I did all new suspension work on it. So I put new springs in the front, new leaf springs in the rear, new U-bolts, and I converted it to power steering. So I no longer have the Armstrong steering. So it makes it a lot easier to park. Other things I've done as well have been, I put a 4-barrel intake and performance headers on it. My first project that I did here at Keene State and intro to woodworking was a Nantucket bench. This was a project that pretty much opened my eyes to the finer aspects of woodworking. I worked with Dr. Habib for the mechatronics trainer course. And I independently put together the candy dispenser portion. I wrote the program using Click PLC programming, and I wired the connections and programmed the PLC. I was also the manufacturing engineer for the Safe Launch Kayak Caddy project. I came up with the idea to knurl the handles to give us better grip when we're pulling it out of the water. This was a very challenging project for us. We went through multiple designs. So here's my DFMA project. This is a tool that I carry on me most days, and it's very handy to have. It's a Milwaukee razor knife with a screwdriver on the back. But basically, I had to research all the materials, price out labor and tooling. I learned about many different types of manufacturing processes, and then I ended up doing a CAD drawing of it. So my next step is a supplier engineer position at Mac Molding in Arlington, Vermont. I start May 31st, 2022. And I'd also like to mention my PD3 project that I just completed this afternoon is in, yeah, it's in our ideation lab up on the table. It's a record storage for vinyl records. I did a lot of metal fabrication for that and some woodworking. So be sure to check that out. I'd like to call up Kate.
I'm Kate O'Leary. I'm also a SPDI major with everyone else. I'm doing an interest with manufacturing engineering. And some things I do on my free time is I love beekeeping. We have 3 beehives at home. We did have 5, but we had to give my uncle 2 of them because his died over the winter time. I like redesigning some of the tools we have for beekeeping, and the picture up in the middle of the Adirondack chair was what really opened my eyes for woodworking. So the Adirondack chair was my first project in woodworking. The first picture I had just did all of the seating, it's all put together. Then the middle picture is me actually attaching the skis to it, and then the last picture is it stained polyed in my front lawn. I also took mechatronics with Professor Habib. I was in charge of some of the wiring and cutting the cup trays to length. This is my product design 2 project. It was for organization, and I had interviewed the swim team because that was a passion of mine right before I came into college. The first picture is I wanted to do something that connected to Keene State, so I decided to do the design of our mascot, which is the owl. The middle picture is some of the requirements. I also had another design that incorporated some parts of an owl. And then the last step is the actual full owl made. The toddler climber is my product design 3 project. Still a work in progress, but I was tasked to create a climber object that would get the little toddlers up to the window because their window is too tall. So the teacher had to lift them up. And I wanted to incorporate aspects of it so that it can help them with their large motor skills, because around that age, they start working on their large motor skills. Here on campus, we have our SPDI Club, which is our SME student chapter. And I was treasurer for a year and a half, 2 years. Our first picture, we try to do an egg drop every year so we can get more people involved. The middle picture is one of our members, Salacia, and she's working on welding a pencil holder. And then last semester, we went to a wind farm. Right there.
Hello, I'm Cartwright Nelson. I like traveling, the outdoors, backpacking, and anything on a board. For my manufacturing enterprise project, I was part of the OYA group and I was the project manager. This was a really exciting project because when I presented the idea, I did not at all think it was going to be possible, but the professors chose it and we ended up getting it done. And it was really cool to see it go from an idea to 8 manufactured projects. So I did a lot of the prototyping for this. I oversaw everything and managed the group with Gantt charts, fishbone diagrams. We did some work instructions, process sheets, and learned a lot about metalwork. For my product design 3 project, I worked with Daniel Henderson. The goal of this project was to help him get outdoors, and to do that, he needed to be able to switch wheels on his wheelchair. It was difficult for him to do this because he had to get out, switch the wheels, and then get back in the wheelchair, which is a pretty timely process. So this was designed to roll back on, lift him off the ground so he could take the wheels off and then replace them. I learned a lot about woodwork. I did a lot of the prototyping and CAD modeling and engineering drawings for this. For product design 2, I designed a tool bag, and this was fun because I got to sketch, go through the ideation and design process, work with material selection to figure out what would work best for this, and then also learn sheet metal on SolidWorks to try to represent what a soft fabric would look like in SolidWorks. And then I used sewing and got to manufacture 4 of these, which was cool. These are just some miscellaneous projects. The top left is an idea that kind of came from the concept poka-yoke, which is doing something without being able to mess it up, basically. It's a pill mug that you put your pill in and you drink water out of, so you automatically swallow the pill. It's for people that forget to take their pills, and then the handle unscrews and you can store all your pills in there. To the right of that is the engine that we had to take apart and then model, and then I 3D printed my part and we put them all back together. Below that is some metalwork I've done, and then on the right was my design for manufacturing project. I chose a backpacking stove, so I got to take the whole thing apart, figure out how it was made, figure out what all of the different materials were, and then cost everything, including labor, material, tooling, and stuff like that. And then at the end, I redesigned the case so that it would fold out and snap onto the bottom of the fuel container so that when you're cooking on uneven surfaces, it adds more stability. This is some of the stuff I did when I was learning Rhino. And then for my CNC class, I actually taught myself SolidWorks CAM instead of Mastercam because I wanted to learn something new. And then I designed this coaster, which we ran out of time, so I never got to actually CNC it, but it was cool to go through the whole coding process and learn a new software. And then this is some stuff I just messed around with recently in Affinity Photo and Designer. It's graphic design, photo editing, and some logos. And then finally, 3 years ago, I got an internship over the summer under New Hampshire Biomade, working with Dr. Habib. And I've been researching under New Hampshire Biomade and New Hampshire Embry ever since. This has been a very exciting experience, and it's been fun to work in a group and go to different conferences and meet new people in the research industry. I work with the bioprinter, the rheometer, the universal testing machine, and a lot of other methods of trying to figure out which materials would work best for this process. And my main focus was material selection and designing a multi-material nozzle system. So I'd like to thank New Hampshire Biomade and Embry for this opportunity, and Professor Habib for mentoring me the last 3 years. And next is Kyle.
All right, so hi, my name is Kyle LeBlanc. I like to go fishing, tinker with mechanical watches, and design and 3D print things. Some of my skills are 3D modeling, rapid prototyping, machine operating, and team management. So this is the project I decided to do for my product design 2 class. I'm a big watch person, so I wanted to try to improve a watch box. One of the biggest problems with watch boxes currently is they're taking up a lot of spaces on desks and tables. So what I wanted to attempt to do is actually move away from that and use, space that's on a wall that's not actually taking up vertical space on something. And I actually laser cut out cardboard here to test the dimensions of it before actually making a second prototype. So this is an exploded view and bill of materials of everything I did for the project. The main part of the box is laser cut out of MDF, as well as the front acrylic piece. And then there was some other hardware and hinges that I used as well. So this actually showcases some of the features of the final prototype. So there's a magnetic strip lock for quick access. You can open and close it real easily. There's a hole in the bottom there for a charging cord. So you can actually put an Apple Watch or some type of smartwatch in the box. I did actually end up putting UV lights in there. It's pretty cool. It actually charges the luminescent markers on the watches, and it also can help combat germs that are left on the watches. And then I also learned how to sew actually, and made some watch pillows that were especially oversized, so it's really easy to take them in and they stay nice and secure. These are some of the CAD models I've done. So the top one is actually part of a weed whacker engine. It was the high pressure pump. So every person in the class took a part of the weed whacker engine, and we all modeled it, and then we put it together for a class assembly. Down there in the bottom, I have this highlighter mechanical pencil 2-in-1 thing that I did for a related pairs project in the introductory CAD class. And then I actually did all of the modeling for the SPDI dry. So there's a concept model that we did originally. We started pretty large, and then we scaled it back to a single filament roll. So I was actually the project manager of the SPDI dry project. This was actually originally my concept. So I did a lot of the design work because we really needed to make sure the tolerances were correct, because we're going for a seal inside the box to make sure that the humidity was going to be consistent. And I was actually also responsible for a lot of the 3D printing. So this is kind of a simplified work instruction of what I was doing. I'd model the parts in SolidWorks, put them into slicing software to prepare them for 3D printing. And then I would print them and then take off the supports and finish the parts so they're good to go on the box. This is actually a project I did in collaboration with Smith's Medical. Shout out to John Tomachik, he's right in the front row. It was a really awesome experience. So the issue was they were seeing about a 600% increase in demand for new syringes during the height of COVID-19. And the issue was a new machine to meet that demand would take around 12 to 18 months to build. So they're looking to bridge the gap and improve the performance of their current machines. So we actually met with some SMEs, and one of the big problems that was that we were experiencing was the plunger tips were actually getting stuck in that singlet wheel that you can see over there. The teeth were actually sharp, so there was pinching the plunger tips and keeping them in place, and it would stop the machine. So what we ended up doing was actually rounding off the tips on the singlet wheel, so that way when the parts are actually passing through the wheel, it's giving it a rounded surface, so there's no way that it can get pinched. And you can see we installed the wheel partway through the day on May 6th of last year. And after that, it appeared that the machine actually wasn't stopping from that fault anymore. And that should be able to reclaim about 1.5 million parts annually. It could be a loss of around 4,200 parts a day from the stops. Congratulations. And next up is Sam. It does? Awesome. And next up is Sam Foley.
Can you guys hear me? Sound good? Cool. All right. Hi, everybody. I'm Sam Foley. A little bit about me. Obviously, like everybody here, sustainable product design major. I love being outside, especially during the winter. I love snowboarding, just being out with friends. Over the summer, I love anything water related, swimming, sailing, anything like that. So into my time as a project manager. So this is specifically in regards to the chaotic motion project that we've talked about a little bit already. I was the project manager for that group, so it was my responsibility to try to keep everybody on track with what we needed to get done. One of the main ways that I took care of doing that was through the use of Gantt charts. This allowed me to note everything that each person in the group needed to do that week, how much they had gotten done on it, and then there was also a more visual way of seeing that information. Another job that I had as the project manager was taking care of any work that may have fallen by the wayside and needed to get done. One example was just some of the more basic accounting. Since I was already the person doing a lot of the ordering, it seemed the most logical to be the person recording that information. So this is a slide about a project that I was working on all semester. The idea here was to create a support system for military helicopter pilots' helmets. As most military operations happen at night, it requires the use of night vision by our pilots. Those systems are extraordinarily heavy and can lead to some serious long-term neck injuries for these pilots. So the idea here was to create some sort of supporting neck brace that wouldn't stop the pilot from being able to look around, incline, and depress their head however they need to while in operation. There's a lot more information about this in my extended portfolio in the other room we can look at later. This is a slide about my time in the ultra precision manufacturing class with Jim Wing in the back there. We spent a lot of time working on programming the machine, actually operating the machine, and then cutting various different types of lenses, just getting a good handle on how somebody actually diamond turns apart. These are some of my various advanced CAD projects. Up in the top, we can see the motor that my advanced CAD class had that semester. My specific part was the actual shell that everything fit inside of, but I was also left in charge of taking care of the final assembly for the entire part for that class. Down on the bottom right, you can see a turbine fan blade that I made and some freeform surfaces that was just sort of a practice. This is from our metrology and CMM class, or coordinate measuring machine. So we had a lot of practice in programming and operating a coordinate measuring machine using PCDMIS 2018 in order to do some quality inspection on parts, make sure that things were up to spec, in tolerance where they needed to be. So over the last 4 years, I have actually been working for Keene State in the IT department. I started as a help desk technician, so I would be the person answering the phone, building some good customer relation skills. And then eventually I started working full-time over my summers and any breaks that I had available as a desktop support technician. So for any of our faculty here, there's a pretty good chance I've broken into your office while you guys weren't here and fixed your computer. I also worked as a classroom emergency response. So if professor's getting ready to teach a class, they come in, they're like, the projector won't turn on and I don't know what's happening. They could call the help desk. I'd get sent over and get them sorted out. Yeah, now on to Amar. Microphone first. I'm going to stand dramatically like this so my mouth is closer to the microphone. So my name is Amar Abatello. I, like everybody else, I'm a sustainable product design and innovation major, but I'm also with the general engineering option. Some of the things I like to do when I'm not, designing things or working on CAD, I really love to cook, really love to kind of go out, see a lot of different nature places, secluded areas. And I also really love coffee, if you couldn't tell by the 2 coffee mugs that are also in this. So the first project I'm going to go over is a organizational design project that we did in Product Design 2. The thing I decided to organize was spices in my own kitchen, and in general, anybody else's kitchen, should they need some organization. I noticed that it's kind of hard to ruffle through all the counters or shelves or wherever people would generally put them. So I wanted them to be all easily visible as well as easily accessible. And what I came up with was this modular design. So by rearranging these different sections here, and you can create a couple different shapes. I have some other shapes I can show later if you'd like to check those out. You can have different amounts of spices. So if you're the kind of person that has 5 spices, you can have a rack that only fits the 5 and only takes up the room for the 5. And more or less, it can fit it all the way up to 24. Next is the Safe Launch project. I was the project manager. So like other project managers, I had to deal with a lot of presentations, keeping everybody on track, making sure everything was happening in the time that it needed to happen. I also did a lot of the initial CAD modeling, which was then handed off to our design engineer, Elle, who did some great renders of those. But did a lot of documentation and planning,
And underneath, you can see some of that documentation. So I have the bill of materials on the left, helped us keep track of the hundreds of bolts that had to go into each design. Some of our work instructions, just a sample of it, and another sample of our Gantt chart, but I'm sure you've heard enough about the Gantt charts already. So here are some of the models that I made for 3D printing. These are the 3D printed components. And on top are the 2 initial models that I had made for the prototype 1 and 2. Learned a lot about team leading, a lot about time management, as well as just a lot of different manufacturing skills with metal, working with woodworking, as well as learning how to deal with PVC and the difficulties that come along with different plastics and trying to shape those. Next is the scanned. This was a project that was designed to be a document scanner phone case. It was made to aid people who are visually impaired, who scan documents to have it read to them. And because of that, obviously, they may have a hard time lining up those documents without a visual cue. So we created this scanner that works with any scanner on the phone that they have, and it can unfold and stand up so that you can get repeatable positioning for any documents like menus in a restaurant or newspapers, as you can see in this picture. And I worked with another designer on this project, Seamus Wibben. He is a great designer. It was great to work with him as well. Next is our design for manufacturing and assembly project. On the left, you can see a couple sections of my costing sheet. My costing sheet was rather long due to the large amount of small components. So you can't see all of it, but I tried to include the important parts. I learned a lot about how overhead affects a manufacturing company, as well as sourcing materials and a whole lot of different aspects that go into manufacturing that many people don't even think about, and it's hard to see from a surface level. So it was really cool to do a deep dive, find out all these aspects, and find out all the processes that go into, well, the products we use every day. Next was the mechatronics module. As you heard from Nathan, me, Nathan, and Colin worked on a new module within the mechatronics trainer to try to complete the loop. So our trainer takes beads, pours them into a cup, sorts them by color and height, and our group's goal was to complete that cycle. So we needed to pick those cups up, dump the beads into the bead dispenser, put the cups back into the cup dispenser, and return back to position so that it can theoretically do a full loop. We did that with a lot of VEX parts, so it's a little hard to see. I know there's a lot going on here, but the green gears that you see here are the design that we came up with. It rotates, lifts the cup up. It'll then tilt back to dump it into the funnel that you can see in very bright blue at the top of the center picture, and then tips the cups back down into the slide to complete the loop. Next is my research internship with Dr. Habib. Did a lot of research looking into biomaterials as well as just engineering in that lane of trying to keep things sterile, trying to make things easily sterilizable, and learned a lot about, well, a lot of things in the field, honestly. But a little bit of context, a bioreactor is designed to, in its simplest form, replicate the conditions within the body. So trying to get the cells oxygen, trying to get them nutrients, and trying to keep them warm and happy and sterile. And this device accomplishes this through a lot of different steps, but it accomplishes it nonetheless. In the far left, you can see the perfusion chamber, or far top left. That is where the cells actually sit in. In the middle of those photos, you can see the oxygen exchange, kind of like the lungs. And then on the far right of that, you can see one of my main additions to the bioreactor designs at whole, which is a pressure modulating device. Taking advantage of the peristaltic pump's properties, it allows us to modulate the pressure within the chamber to try to give it the same cues that a human body would when you're actually, moving around, your heart's beating, a lot of pressure changes. Here you can see a close-up of the perfusion chamber and the perfusion cassette specifically, which is also customizable. It's another thing. You can hear all about it if you come and talk to me afterwards. I can talk your ear off about it. But on the very bottom here, you can see some of the computational fluid dynamics analysis that I conducted on the chamber to try to refine and make sure that my idea was going to work properly when we do implement it with our full scaffolds. And yeah, I'd also like to give a big thanks, obviously, to Dr. Habib for bringing me into this research, teaching me a lot, as well as a really big thanks to Warren and Curtis, who, without them, most of my projects would not have been finished on time and perhaps even finished at all. So big thanks to them, a lot of help from them, and I really appreciate all that. And on to our more formal thank yous.
First off, I'd like to thank everyone for coming. Thank you to all the companies that have given us the opportunity to work with them. And I'd like to give a special thanks to Hitchner, Wheelan, Markham Image for sponsoring the Manufacturing Partners Scholarship.
We'd also like to thank all of our faculty and staff, mainly Dr. Lisa Hicks, Dr. Habib, Professor Nelson, Curtis Mead, and Warren Hurd. If we could just get a round of applause for those guys. And now we invite you all to join us back in the main lobby and in the Speedy Lab to meet up with all of our students to take a closer look at some of our projects. Thank you.
And just one last thank you guys. This is awesome. So yeah, I've worked with these students for the last 4 years, and it's amazing. I know that the work they've done, but it's just amazing to see it all put together and see how much you've learned and how much you've accomplished. So anyway, one more round of applause. Now there is one little last thing before we go, and this was really hard because we usually do a speedy outstanding speedy student awards, and there was so many, like they're all outstanding, and so the only way we could figure it out was the highest GPAs, because you all are amazing anyway. So we've got 2 outstanding student awards, speedy student awards, one to Amr and one to William. So come on up. Just so you know, so we don't have to wait for them to open them, these are dial calipers that are engraved with your names on them. So no one, they'll be yours forever. So anyway, so please join us in the labs. Thank you.